The non-positive displacement vapor compression cycle has much in common with the positive displacement compressor cycle. It is used in centrifugal chillers. Let's look at a specific example, using typical temperatures and pressures for the centrifugal chillers sold currently. Our example is a centrifugal chiller with a water-cooled condenser. The system is charged with a high-pressure refrigerant, HFC 134A. Chilled water leaves the evaporator, also called a cooler, at 45 degrees. Cooling tower water is entering the condenser at 85 degrees. Refrigerant pressures and temperatures vary widely based on the type of tubes in the heat exchanger, whether brine or freshwater solution is used, the pass arrangement on the heat exchanger, and the water flow rate. Values are normally found in the chiller design data specifications. Let's start the cycle as liquid refrigerant flows into the evaporator, a flooded shell and tube heat exchanger with chilled water in the tubes and liquid refrigerant in the shell around the tubes. We call it flooded because the liquid refrigerant covers the chilled water tubes. The centrifugal compressor continuously draws refrigerant vapor from the evaporator, maintaining evaporator pressure at 39 psig, which corresponds to a saturated evaporation temperature of 44 degrees. The 44-degree liquid refrigerant picks up heat from the chilled water flowing through the tubes, causing the refrigerant to evaporate and cooling the chilled water from 55 degrees to 45 degrees. This chilled water is distributed to fan coils, which cool, dehumidify, and filter the indoor air. There is very little superheat in the vapor leaving the flooded evaporator. The refrigerant vapor is drawn from the cooler or evaporator by the centrifugal compressor at the rate set by the inlet guide vanes. It is compressed to a pressure of about 120 psig, with a corresponding saturated condensing temperature of 98 degrees Fahrenheit, and then discharged into the condenser. This compression process adds some heat to the compressed vapor, superheating its temperature to about 120 degrees. In an actual building, this temperature may vary based on the load and the machine's refrigerant charge. The water-cooled condenser is a shell and tube heat exchanger similar to the evaporator. Cooling tower water at 85 degrees flows through the tubes, removing heat from the refrigerant vapor, causing it to condense on the outside of the tubes. Remember that the saturated condensing temperature of the refrigerant vapor is 98 degrees, causing heat to be transferred to the cooling tower water. The condensed liquid refrigerant drains to the bottom of the shell, where it passes through orifices into the flask subcooler, where it is subcooled about 10 degrees, as some of the liquid flashes to a vapor. The cycle is completed as the subcooled liquid refrigerant flows through the metering device and returns to the evaporator. The metering device in the centrifugal refrigeration cycle may be either a float valve or a poppet valve. Here, the float valve controls the flow of liquid refrigerant between the condenser pressure of 120 psig and the evaporator pressure of 39 pounds. The float maintains a refrigerant level in the float chamber, which provides a positive liquid seal and prevents condenser vapor from blowing directly into the evaporator. When the liquid passes through the metering device, some of it flashes to a vapor at the lower pressure on the evaporator side. In flashing, it removes heat from the remaining liquid, lowering its temperature to 44 degrees. The cold liquid refrigerant then flows into the evaporator, where the cycle can begin again. This is the mechanical non-positive displacement vapor compression refrigeration cycle using a centrifugal compressor. Before closing this section, a few words about refrigerants. The HFC 134A used in our example is a high-pressure or positive pressure refrigerant. Low-pressure refrigerants can also be used in centrifugal refrigeration systems. These refrigerants, such as HCFC 123, operate at pressures below atmospheric in the evaporator and above atmospheric in the condenser. Please take a moment to complete the following learning activity. To continue, make your selection.